Page 37, number 7 and 8.
You should promote it, buy it though. Or there's something. So I was interested in.
You have one at home? Excellent. Yeah, perfect. Thank you.
How was it? How was the one thing at the I haven't. Sorry. I like your earrings this band.
Oh, thank you. They're fun.
Never mind them. Yeah. Yeah, I have from earrings. It was stuck in the back. My skin broke over it. It was stuck in my 3 times, and it's so painful.
No. If you don't keep track of where everything goes. We did this. Yeah. So what you're going to do is convert both to the power sort of pick one from, and then change this one, say to 2, and then you go get bigger. This has to go. Add the coefficients once the power of 10 is the same. Yeah. So basically what we're doing is we're using the principle that you do have factor common factors. So we have the same power of 10. Factor out the power of 10 and go out to 4 plus 2. Yeah. We can do that with sig base, right? So we have this plus this plus that. And just adding uncertain digits. Now, if we have different powers of 10, then they don't have to be the same. We're going to be able to factor it out. And not the same. Okay, that's the general idea anyway.
Is it quiz tomorrow?
It's quiz tomorrow. Yeah, if you're not quite ready for it, that's fine. Just let me know, okay? Yeah.
Oh, yes, yes,
It makes both the same power of 10. Yes. So you can want to use 5. Yes, exactly. And then
I know where I put so video today. I was reading the problem the door. Right? But if you talk up to the behind, like, you need something. I was like, oh no, I'm not gonna run.
yes.
I'm scared away. Were you in a class? No. Oh, you know, we went to class. We were in the same class together. Yeah. As you know, did you have bubble tea? Yeah, I like that.
No, that's just
I lost my phone there. You know how to? So this one's based on Jesus. So tomorrow, the calculation that we're gonna do, like on test, it's gonna be scientific notations.
All of it.
All of it.
So scientific notation, non-scientific notation, single step, multi-step,
They're all gonna.
everything's in there. Yeah, yeah. So did we all get 7 times 10 to the 4 for number 7? Or are we still working on it? How many people got that? Tomorrow? Thursday. How many people are still working? Okay, take a minute and finish up.
Oh, the first uncertain digit.
Uh-huh. So if you're doing that first question, if you did not get 7 times 10 to the 4, you got something else. Remember, you have to change the 2 powers of 10 so that they are the same. Okay, so that we've got both of them times 10 to the 5. Or if you did 10 to the 4, that's also good. Okay, you could have changed it the other way as well. And then you factor out your coefficients. And then you do the subtraction and get 0.67. Now, my uncertain digit is in the 0.1 and in the 0.01. So that's the 0.1 and the 0.01. So I have to now round to my first uncertain digit, which is here. We look to the right, and that is going to become 0.7 times 10 to the 5. But that's not in scientific notation. So we would change that then to 7 times 10 to the 4. It is. I think I may actually have worked it out. I think if you're adding, it's better to go to the larger power of 10. And if you're subtracting, it's better to go to the lower power of 10. That's my guess. I could be wrong. I think I might be right. Which after like 30 some odd years is like, it's taken me a long while to get there.
Sorry.
That's okay.
It's really hard. That's not hard. It's really easy.
It's just like a little picky detail that I've never noticed before. Okay, so that is how you would do that. How many people have finished number 8? Okay, a couple of you. If you want to go on and do number 9 while you're waiting for the rest of us, you can. This is a subtraction. I'm going to try the go to the lower power.
Oh my God.
I don't think it works here. Oh, well. That's irritating. No, it didn't work. I went to the higher power and it didn't work. Or the lower power. Oh, well.
It's all right.
Maybe that's why I've never figured it out, because it doesn't work. You should get 1.9 times 10 to the negative 1.
Yes.
Did you get 1.9 times 10 to the negative 1? If not, I went to the power of negative 2 this time. So I changed both of them so they were 10 to the negative 2. You could do it to 10 to the negative 1. It doesn't matter. That means we now have 24 minus 5.5 times 10 to the negative 2. 24 minus 5.5 is 18.5. But we're doing subtraction. So our uncertain digit is a 4 and a... Are you talking while I'm talking so much right in front of me? It's okay. Okay, so we have 18.5 times 10 to the negative 2. And that means that we've got uncertainty in the ones position because of that 4. And we have uncertainty in the 0.1 position because of that 5. And that means we need to look to the right. And that becomes 19 times 10 to the negative 2, which becomes 1.9 times 10 to the negative 1. I also wanted to ask if anyone had any questions from page 37, or not page 37, page 41? Yeah, 41. Were there any in here that you would like to go over?
For number 7.
For number 7, yes.
It's BEDMAS rules, right?
Yes.
Do the 25
Yeah, you do these ones first, and then you do the subtraction, yes.
Okay, so it's like it follows the normal BEDMAS rules.
Yes.
Find
Absolutely.
the
Yeah.
All right. Okay.
Everyone was perfectly good with these? No problems? I know I had a couple people drop by during Flex this morning. I just want to say, if you ever have a question, you can drop by during Flex. I was here all lunch hour. You can drop by during lunch hour. You know, if you're like, oh my gosh, I did not wake up in time for a Flex. Very often I'm here at lunch, especially if you come at the beginning of lunch hour, then I'm here. So do ask questions. It is how you get your questions answered, and it's how you do better on tests. Oh, and speaking of which, on Thursday, this has nothing to do with that. There's a convoluted pathway in my mind that connected them, but it won't make any sense to you. On Thursday, in Ms. Lamb's room, do you guys know where Ms. Lamb's room is? So you go like all the way around, and it's like second from the end over there. Okay. In Ms. Lamb's room at lunch tomorrow, they're having a speaker from UBC. Sustainability. She works in sustainability and she has done many presentations before, so she's really good at it. So if you're interested in either sustainability or going to UBC, she would be an excellent person whose brain to pick. Yes? So she will be around tomorrow at lunch over in Ms. Lamb's room. Okay? All right. So no questions. All right. How about you do number 17? Just for fun. Number 17. We're going to get rid of those diamonds now. Number 17. Oh, and take notice that there's a -2 and a +2 on the top. That's irritating. I would recommend doing the top, then the bottom, and then doing the division. So if you finish the top, you can check and see if you got the same answer as I did. And you can see if I'm right. Sometimes I do things wrong. So it's always possible. Did I do it wrong? Yeah. Uh-oh, where did I go wrong?
For the second line, is 1.381, but
Oh, and I forgot the 1.381. Thank you. Thank you, thank you. There we go. That's better.
Oh, it's so sad. Isn't there 5 big picture models?
Nope, because the first uncertain digit is the 1.
Oh, and that one was there.
That one's just there because I don't want to do a rounding error.
Oh, yeah.
I mean, I could have written 1.381521, but that's irritating to have to write again, and I don't have very much room.
Yeah.
So I kept only 1 digit in addition,
Wait, one did the other one.
in addition to the uncertain digit. Yeah. So fingers crossed I did it correctly. If you got something different, please let me know because I often make boo-boos. I am an error-prone person. Well, let me try it again. 1.3815 E2 divided by 1.1
Oh, you put the E2 there.
E1. Yeah? E2?
No, because you don't, but I just divided it and subtracted the exponents. So I divided the number.
Okay.
And then I subtract the exponents.
So you get 10 to the 1.
10 to 1.
So you got 1.1.
I got 1.177 times 10 to the 1.
Yes, which is the same as 11.77 times 10 to the 1. Yeah. 1.177 times 10 to the 1.
Oh, yeah.
That's just times 10. Yeah. So it's 11.77.
Oh, yeah.
Same answer. And if you wrote it either way, it would be fine. It's correct either way. It's a little bit weird to write it this way just because 11.77 is a lovely normal number. Do you know what I mean? Like it doesn't have zeros all the way over here or all the way over there. It's just a nice normal number. But that being said, this is fine also. Okay? Yeah. How did we do with that one? There's only one question like that on your quiz. Most of the other stuff is not quite so gross, right? On your quiz, there will be 1-step addition, 1-step subtraction, 1-step multiplication, 1-step division. There will be scientific notation. There will be non-scientific notation. There's going to be everything from 2.1 and 2.2. Okay? If you need extra practice, tonight we have our big sig fig review, which starts on page 42. You might find that you don't need to do the first part because the first part is like all the basic rules about counting sig figs. Okay, on page 42. You might be like, okay, I need to more like move into page, part B is just counting sig figs. Part C is rounding off. Maybe I don't need to do that either. You could just start with part D. Okay, and that would be a good review. And then part E, calculations, all kinds of calculations, and more calculations, and more calculations. So, should you do every single calculation? No, right? That might drive you crazy, right? Because we've got like pages, I don't know, 45, 44, 43, 42, like pages and pages. But should you look, and let's on page 45, we're going to get rid of these doodads here. Get rid of these little doodads. All of it's fair game. Okay? All fair game.
What about 69 and 70?
69 and 70, no, don't worry about it. Okay? I would not worry about it. Do not worry. Sig figs are used for measurements. What's meant by sig figs? All the certain digits plus one uncertain digit. That's it. But I'm not going to ask you that on your quiz. It's all calculations.
And showing our work would be hard.
You do not need to show any work. There is a space provided for rough work, right? But I'm not going to mark your work. If, however, you get it wrong, and I can see where you've gone wrong in your work, I might be like, oh, you went wrong here. Do you know what I mean? Like I can give you feedback, but it's your answer is either going to be correct or incorrect, right? So we good? Shall we move on to 2.3? Yay! Okay. So here we are on page 46. 46. And I know you're like, oh my God, finally, no more sig figs. But every question that you answer from this point in your chemistry career, if it has numbers, it should be given to correct sig figs. The nice thing is, though, that if you look at unit conversions, they are all multiplications and divisions. And what's the easiest rule to work with? Multiplication and division. So all the crazy sig figs, we can mostly not worry about those. Yes? They're in this unit because they have to be in this unit, but mainly we're done with the crazy ones. Now we're just down to the basics. So what is this business of dimensional analysis, also known as conversion factors, using unit conversion using conversion factors? A conversion factor is something where you have two things that are equal. So for example, if you happen to be conversant in imperial measurements, there are 36 inches in 1 yard. "36 inches in 1 yard. Okay? That is an equality. And you know lots of equalities. You know how many hours are in a day? 24 hours per 1 day. Okay? That can become a conversion factor. And how we make it a conversion factor is we write one of the numbers over top of the other number. And if it's 36 inches per yard, you can just write it as 36 inches over yards, or you can write it over 1 yard. That one doesn't matter whether it's there or not. Okay? What this is going to allow us to do is it is going to allow us to convert between inches and yards. So our question then is, how many inches? How many inches? That is our unknown quantity. Okay, so in every question, you should identify who is the unknown. And how do you do that? You look for question words. Okay? You should also identify what we call the initial quantity. The initial quantity is what you are given. Okay, so what am I given? I am given 2 yards. And I made kind of a boo-boo here. This shouldn't just be 2 yards. I need to fix this because it should be 2.0 yards because we care about sig figs. Okay? anytime you do a conversion, you're going to say, I want to solve for my unknown. So I'm going to put, what am I solving for? Equals, you're going to start with your initial quantity and you are going to multiply it by your conversion factor. So it's always going to be your unknown is equal to your initial times your conversion factor. All right? And we'll get into things where we do unknown equals initial times conversion factor times conversion factor times conversion factor. All right? But for now, we're going to just start with 1. All right? So we have our number of inches. Our initial quantity is our 2.0 yards. And I want to end up with inches. Why am I highlighting green and green? That's terrible. Let me pick a different color. There we go. Okay, I want to find my number of inches. Now, that means that I need inches on the top, so I end up with inches in the answer. And I need to make sure that I am canceling the yards out. And if I have yards on the top and yards on the bottom, they cancel out, because that's how math works, right? If you have something on the top and something on the bottom, they cancel out. Yes? And so you just go 2 yards times 36 inches per yard and you get 72 inches. And maybe, and probably, you could do that without using this method. Yes? But the reason that you should pay attention to this and do it this way is that, well, there's several reasons. Basically, it just works. It works so well. Have I got my little speech in here? I actually wrote out this big, huge speech. Oh yeah, here we go. On page 48. Okay, so why call this dimensional analysis? Wouldn't unit conversion be easier? Yes, but that's how they refer to it in uni. So we'll try to get used to the term. This is page 48. 48. Why bother with this? I could do this in my head. This is the one skill. I've actually had students come back after graduation and tell me they have used it in their everyday life. Okay? People are like, what use is this to me in life? Unit conversion is useful to you in everyday life. Both my husband and I, fix X. Okay, anyway, sorry. After this. How does one deal with that? One has it written in a book. Anyway, I use it in our daily lives. We do. We use it in our daily lives. Okay, not just for school. It is incredibly useful. Now, learning a skill works better when you first learn and practice in a simple context, which is why these examples, you're going to be like, I could do this in my head. Yes, I know you could, but do the stuff you can do in your head while practicing times, line, cancel your units, getting used to that pattern, okay, is better. The next one, you can easily see if you've made a mistake, because if your units don't cancel out properly, then you're out of luck. Yes? So you can see if you've made a mistake. It makes your work clear to your audience. This is huge. If you were doing chemistry in your basement by yourself, for yourself, and you wanted to write it and you never wanted anyone else to read it, write your work however you want to. But you will be presenting it to me. If you take Chem 12, you'll either be presenting it to me or Mr. Weinberg or Ms. Wu. If you go to uni, you'll be presenting it to professors. And I've actually been told by instructors at SFU who've seen them, that students from Mountain to show their calculations very clearly. Yes. Okay? And that's because all of us here teach you how to use this method. And it makes it very clear so your TA can understand, so your prof can understand. And it makes it easier to give you part marks. If you have all this stuff going on in your head and you're like, there's the answer, and you got it wrong, then I'm like, well, I guess that's a 0 out of 4 for you. right? Whereas if you've shown all your work and you just made one little mistake here, I can be like, oh, that's a 3.5 out of 4, right? It makes solving complex problems manageable. So what we have here is halfway through this course, you're going to have a question like this. What volume of 4.0 moles per liter, you remember that mole, the amount of matter? Moles per liter HCl must be reacted with zinc to produce 3.5 liters of hydrogen gas at STP. We have a balanced chemical equation there. We have some conversion factors that you will learn in the mole unit. Okay, and here we have our unknown. In the question, we are given our unknown, what volume, that's our unknown, are given our initial quantity is 3.5 liters, so we have our initial quantity. And then all we have to do is make sure that everything cancels. So if I have liters of H2 on the top, I need to have liters of H2 on the bottom. So they cancel out. If I have moles of H2 on the top, I need to make sure that in my next step, I have moles of H2 on the bottom. If I have moles of HCl on the top, I need to make sure on the next step I have moles of HCl on the bottom. And then I look back and I say, what was I looking for? I was looking for liters. Did I end up with liters? Yes, I did. Hooray. Okay? It makes a problem like that manageable. And you might look at this and you'll be like, how is that manageable? But by the time we get there, you will know all these conversion factors almost as well as you know 60 seconds in a minute. You know what I mean? You can use 60 seconds in a minute right now because you know 60 seconds over 1 minute. Okay? That's why. And why do I have that in there? Because every year there's like one person who insists that they know better than I do. They insist that they know better than Ms. Wu does. We have both collectively been teaching for over 25 years. That is over 50 years of teaching experience. And we're like, the students who don't learn how to do this don't succeed. They get stuck at some point. They're like, doing great. I can do it. Stoichiometry, bam, the brakes hit and they fall apart. Okay? Don't fall apart. Learn it now, do it now. All right, now, back to why this works. Do you remember we said that a conversion factor comes from an equality? The two things are equal to each other, yes? And if two things are equal to each other, like if I put a 3, let's say I put a 6 over a 3 times 2, those two things are equal, yes? What do I get when I divide two equal things? I get the number 1. So I can multiply by a conversion factor, and it is though I am multiplying by the number 1 over and over. So everything will continue to be equal, because if I take 10 and I multiply it by 6 over 3 times 2, that's 10 times 1, which is 10. That's my original number, right? So I can just keep multiplying and I will end up with, in this case, it won't be the same number because we're changing units, but they will be equal to each other. Okay, the two ends will be equal. So anytime you have an equality, you can make a conversion factor. And you cannot just make one conversion factor, you can make 2, because you can write it right side up. I don't even know which way is right side up, but you could put 36 inches on the top, or you could put 36 inches on the bottom, just depending on where you need it to go. Okay? We're going to just skip over this here. La, 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 la. All conversion factors equal 1. Blah, blah, blah. This is just theory. Yes?
Can you also say if you write how many yards are in 1 inch?
Yes.
But that's not a nice.
You could, but it's not a nice number. Exactly. It's like, I don't know, whatever 1 over 36 is.
Yeah.
Yeah.
So we want to work with
It doesn't matter. You can work with whatever kind of number you want to, but usually if it's imperial, you'll be given it in the question. If it's metric, then you're going to be like mega, kilo, deci, centi, milli, micro, nano. Oh, I'm doing nanograms. It's 10 to the negative 9 grams.
Right.
Yeah? Okay. All right. What happens if we choose the wrong form of the conversion factor? So, how many feet is 35 yards? And we are told our equality this is on page 47. Halfway down the page. 47, halfway down the page. How many feet is 35 yards? We're told that 1 yard is 3 feet, so we can have the conversion factor either written as 1 yard for every 3 feet or as 3 feet per 1 yard, and we have to choose the correct way to do it. Our unknown, how many feet? There's our question word. So that's our question. So that's going to be our unknown, is the feet. 35 yards, that is our initial quantity. Okay? Whatever you're given is the initial quantity. 35 yards is what you're given. Remember, the initial is the given. Our unknown is equal to our initial times the conversion factor. Excellent. So we're going to say my unknown, I don't know how many feet, is equal to my initial quantity, 35 yards, times my conversion factor. Now, what if I chose 1 yard over 3 feet? What if I chose to do it this way?
It wouldn't work. The yards would cancel.
Do you see how the yards do not cancel out? Okay, so instead you would end up with yards squared, and the feet are not canceled with anything, so we have now yards squared over feet, and you'd be like, what the heck is a yard squared over feet? Which is one reason why when you do your unit conversion, writing it out this way will keep you from making stupid mistakes like that. Like if you try and do it all in your head, it's easy to get a conversion factor upside down by mistake. But if you write it out, you'll see, oh, my units didn't cancel. I must flip that conversion factor over. Okay? You can always flip a conversion factor upside down, even if it's given to you 24 hours per day. That can easily become 1 day per 24 hours. All right? Doesn't matter. Blah, 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 blah. And we are now on page 49. Okay, let's do this together here. How many days is 360 hours? I am going to suggest to you when you first start out that you write down your unknown. What is our unknown here?
The days.
How many days, right? So I don't know how many days. Our initial quantity is whatever we're given. 360 hours. And our conversion factor, if we are not given one in the question, that means it's something that we should know. Do we know a conversion factor between hours and days? 1 day is 24 hours, so we're going to write 1 day per 24 hours, or you could have 24 hours per 1 day. Doesn't matter which one. UIC. Unknown is equal to initial times conversion factor. So our unknown, I don't know how many days. Please show that. Okay? Show this. Equals our initial quantity, which is 360 hours. And then I usually like to do it like this. I just write times line. Times line. I write times line, and then I like to fill in the units. I say to myself, what unit do I want to cancel? What unit do I want to cancel? We want to cancel hours. So I'm going to write hours down here. I'm not even writing in numbers. I know this seems foolish right now because you're like, I could just slam things in there, but I'm showing you how you might do it for a more complex problem. Okay? Hours, those are now going to cancel it. That's going to be beautiful. What do I want to find? Days. So days is going to go on the top. Okay? And now I say to myself, do I know a conversion factor between days and hours? I know that there are 24 hours in one day. So I tend to do number 1, times line, number 2, the units, and then number 3, I put in the numbers in the conversion factor. Okay? And then you do 360 divided by 24 equals 15 days. And I look at my sig figs now. How many sig figs in 360? 2 sig figs. How many in the 1?
But infinite.
Infinite sig figs because it's defined. And how about in the 24? Infinite as well because we define one day as being 24 hours. Okay? So there we are. And oh, look, we have 2 sig figs. Isn't that beautiful? And I would recommend that you box your final answer because it's like, look, here's my answer. Even if you don't understand all my writing, here it is. Look, look, look. Yes?
But, okay. Say, I don't know, but say it wasn't in the proper order of 6 days. Would you write it as times then?
I would generally not write my a number like that in scientific notation.
Right, but what if, like, hypothetically, not exactly this, maybe like later on, if things not in the proper order of 6 days.
Okay, so what I would do is if my number was like this, I would write that in scientific notation because it's got too many zeros in it.
Yeah.
Okay? Doesn't matter about sig figs. It matters how many zeros you have. Right? So if I had a number like scientific notation, too many zeros. If you look at it and you're like, those zeros make my head hurt, I would have to count them, then write it in scientific notation. If it's a nice number, 430, oh, that's a nice number. That's not too many zeros, right? 0.003, that's all right. You know, I mean, you could write that as 3 times 10 to the negative 3. That's fine. You know, it's kind of like, I always say, like, for exponent of 1 and exponent of 2, I would just write it in standard notation. Okay, exponent of 3, you can kind of go either way. Exponent of 4, I would tend to write it in scientific notation as opposed to
Right. What are we going to do? Maybe not scientific notation specifically. What are we going to do if the answer doesn't have the proper amount of sig figs?
Then I would say if I needed 3 sig figs, I'd go 15.0.
Oh.
Yeah?
Just a 0. Yeah. Okay.
Yeah? Yeah. I finally answered your question.
Yeah.
I managed to not answer your question for quite a while there.
It's all right.
Yeah. All right. So you guys have a job now. Your job is to do these questions on pages 49 and 50. And if you have any extra time, you can study for your quiz tomorrow because it's a big one. Okay? Pages 49 to 50. Extra time. Study for quiz. Big sig fig review.
Can I check my grade?
Yes.
Yeah.
And if you're like, I have done this in physics and this is way too easy, you can feel free to work ahead.
Let me find myself right there.
Of course. It's pretty fucking cool. Yeah.
You can feel free to work ahead to 2.3b if you want to. Okay, multiple unit conversions. And eventually we'll get to squared and cubed.